Hello, respected Johari. Today, me, Sarthak, and my partner Samyak, we are going to present our topic: the future of cryptocurrency market analysis, social media data, and user metadata. So now we can see that the world is moving to the digital space pretty fast, and cryptocurrency has emerged as a secure form of currency. But we see that the cryptocurrency exchange is an extremely volatile market that operates differently from your normal market. And which is why it becomes very important to try to predict how the behavior of cryptocurrencies is going to be. And that was our motivation. We try to analyze the fluctuation of cryptocurrencies from each bracket, and we do it for 2 coins from large cap, which are Solana and Avalanche, and 3 from mid cap range, which are Dogecoin, Matic, and Shiba Inu. Now, here is an example that we have shown how Elon Musk caused a huge fluctuation in the market of Bitcoin. And the tweet was about how it suspended vehicle purchase using Bitcoin, which made the Bitcoin prices drop by 15%. We have collected tweets and related data along with price related from two large cap and 3 mid cap cryptocurrencies, as mentioned before. We then performed sentiment analysis. For that, we used Roberta, and then we analyze the effect of sentiments on the corresponding cryptocurrency prices. We also use sentiment analysis based feature with collected metadata related to the tweet and user to perform the task of price prediction. Our project aims to capture the effect of sentiment of tweets regarding a cryptocurrency. We capture the sentiment of the tweet and we use the metadata related to the tweet, and we combine the two as features and try to do price prediction. Here is a brief description, a brief schema of our model. We first take the tweet text, we pre-process it, and we perform sentiment analysis on it. Along with that, we use tweet metadata, and then we combine it and put it into our model along with the crypto data, which is the prices of cryptocurrency at different time intervals. And then we use that to make correlation and analysis. For literature review, we searched through many papers, and these were some of the most relevant papers that we found related to our research. This paper in particular predicts the changes in Bitcoin and Ethereum. They collected tweets from Twitter API, and then they used Vader to perform sentiment analysis. They found a positive correlation of prices with sentiment, with our price was raised. Next, this paper tries to predict the 2-hour price of cryptocurrency, namely for Bitcoin and Litecoin, with the help of multi-layer regression models. The prices of the two Bitcoins are extracted with the help of CoinDesk. The proposal of multi-layer regression model is able to predict the 2-hour prices of Bitcoin and Litecoin up to R2 value of 44 and 59% respectively. This paper explores the use of social sentiment data as a better predictor as compared to the traditional methods of using technical financial indicators, and uses the non-linear relation between the sentiment and Bitcoin prices to predict the prices in future. This paper so this paper uses historical tweet data fetched from Twitter. The paper broadly works on 2 aspects: implementing a predictive model that uses momentum metric, providing explainability on the above implementation by using unsupervised deep learning clustering models. This again works with the help of Twitter sentiment analysis in order to predict the changes in the prices of cryptocurrencies such as Bitcoins. It uses random forest regression, and a 62% accuracy was observed in their predictions. Now for the data set. For extracting data set, we have used the TweePy library, and the cryptocurrency prices was extracted with the help of Crypto Compare API. Here are the fields that we have mainly worked on, and these are the metadata that we are talking about when we mention the metadata of a tweet. We use the tweet ID, the tweet text, which is relevant for sentiment analysis, and then the retweet count created at, which is very important when we are comparing it to the cryptocurrency prices. and then other details related to the user, like friend count, favorite count, etc., and the place where the tweet has been made. Fields collected in cryptocurrency prices are time, high, low, and volume from the total amount of base currency traded into cryptocurrency during that minute, and then the volume 2, total amount of cryptocurrency traded into base currency during that minute. Close the price at the end of the minute. For pre-processing, the collected tweet data, including the tweet text, which was pre-processed, is needed for sentiment analysis. The user data was present in the form of JSON, and we have to pre-process it in order to use it in our sentiment analysis. The pre-processing steps are as follows. We removed user mention present and handled retweets, removed any links or URLs which are present in the tweet text, separated the hashtags, converted tweets to lowercase, removed punctuation, and this was a very important part. We kept emoticons and we classified them as follows. For example, a smiley face was used as smile, a flushed face was used as flushed. So all these were very important when we wanted to compare how the sentiment of the tweet is, and it played a very important role in our sentiment analysis. Now for outlier detection, for example, in the case of avalanche, we found that there were many tweets which contained the word avalanche, but were not related to cryptocurrency avalanche. Upon further research, we found that there were multiple other meanings related to the word avalanche, such as the football team. For this problem, we created our own detailed list of crypto and financial terms and classified the data into crypto or non-crypto categories. We kept stop words, and this was very important. As you can see in our example that we have shown above, Bitcoins is not a good investment. This is a negative sentiment. However, if we remove the stop words, it would become Bitcoin good investment, which is a positive sentiment. Hence, this keeping stop words was relevant for our research. We then created word clouds in order to get a basic idea about what mostly is being talked about in the tweet. Now we wanted to see how the verified status of a user is responsible in order to understand how people behave on that tweet. And we see that if a user is verified, we see a greater response and a greater retweet count and favorite count can be seen in the case of verified users. The average length of the tweet were also calculated. And now we go for methodology, and Samyak would take over.
Yeah, so first part of our methodology was performing sentiment analysis, which is a pretty basic NLP task of categorizing the opinions that are present in a text into a particular sentiment, which is generally a negative, neutral, or a positive sentiment. So for our problem, we did not have any sentiment label attached to our tweets. So we made use of this particular pre-trained model, Twitter Roberta based sentiment, which was trained on around 58 million tweets, and it was already fine-tuned for the sentiment analysis with the tweet eval benchmark. This is a basic description of Roberta and how it is actually being pre-trained. So in the interest of time, I'll basically skip on this. For our prediction models, we make use of two very basic models and some tree-based models like random forest, and also deep neural network models like a combination of LSTM with multiple linear layers. So firstly, as a part of our prediction model, we make use of linear regression, which is basically fitting a linear model with the help of weight coefficients to optimize a particular loss function, which can be reducing the sum of squares between the actual value and the predicted values. Next, we make use of an SGD regressor, which builds an estimator using a regularized version of a linear model. The regularizer does add a penalty that further helps optimize the model parameters, and it does follow the stochastic gradient descent method. For tree-based models, we make use of random forest regressor, which is an ensemble method that tries to improve the predictive power of a model by fitting multiple decision trees and averaging across that. As a part of our test setup, we split our data into trained test ratio of 70-30, and this is a basic description of the various parameters used for different models. For performance analysis of our predictive models, we make use of two measures, which is mean absolute error, which is essentially the modular sum of differences between the predicted and predicted and the actual value, and the root mean square error, which is the squared sum of differences averaged along all the data points for the predicted and the actual value. In addition to this, we also use a metric called percentage error, which is simply the absolute error, represented as a percentage of the original value. We also make use of LSTM-based models. So we make use of LSTM so as to incorporate some sort of time context into our models. And we tried various stacked combinations, and we used a combination of LSTM with fully connected layers to obtain the final prediction. We train it for 200 epochs with a learning rate of 80-4 and a hidden size of 16. So this is basically our model architecture, where we feed input into a LSTM block, and we then use a dropout layer, and then we pass it through a fully connected layer followed by ReLU activation, and again a dropout layer. And then again, for a final prediction, we pass it through a fully connected layer and apply the sigmoid activation function to get our predicted output. Now I'll move on to the results and analysis section. So the baseline models were trained on the features data set, and the coin price is predicted. And following are the results for the MAE and the RMSE for linear regression, SGD regressor, and the random forest method. Here we can see that for almost all the cryptocurrencies, these three models have a comparable performance, and there is no such performance improvement that is being observed as a part of one particular model. However, in general, we can see a trend that the random forest regressor does tend to perform better than its counterpart linear models, such as the linear regression and the SGD regression. These are the loss curves that we had for SGD regressor, and we can see that the loss does decrease with increasing epochs for both Avalanche and Matic, which are two large cap cryptocurrencies. And these are the results we got for the percentage error, which are again follow the same trend as I explained in the previous slide. And we can see that in general, the high cap currencies that are Avalanche and Solana tend to have higher loss values, which indicates the model does not learn to optimally predict its prices. These simple models do not optimally predict these prices. And also a very key thing to note here is that we are missing the context of time here, because these linear models do not capture any sort of information about the previous prices and the previous feature data. So in such a problem where time is the time axis is of such critical importance, we are completely missing that information in these simple linear models. So for our we tried our LSTM based deep neural network model for this particular thing, and we observed that a significant improvement for MAE and RMSE, and also the percentage error when compared with the different baseline models. And also here we explain a trend of how the price fluctuation prediction differs without including metadata and after including metadata. So we did observe a bit of noise after we included metadata for this particular Dogecoin. This presents the difference without including metadata and including metadata for the Avalanche coin. However, we can still see that the performance does not differ that much. And we did compare it with the baselines in SOTA, and the thing is that we cannot have an apples to apples comparison here, because most of the work does happen for the pretty popular cryptocurrencies such as Bitcoin and Litecoin and Ethereum. So, but for Bitcoin prediction, the SOTA did report a percentage error of 43%, and comparing the percentage error with the large cap and small cap cryptocurrencies that we study, our model tends to perform better. So we also analyzed the performance of our sentiment analysis component, and for that, what we did was we converted the tweet text of all the tweets into their 768 sized representation using a sentence tokenizer, and then we performed PCA on it to analyze if the tweets that have same sentence tokenizer based representation tend to be from the same sentiment group. And we did observe this observation that the tweets that have similar representation in terms of their contextual embeddings do tend to group into same sentiment class. And this is a general analysis of the distribution of sentiment for the tweets of various cryptocurrencies. Most of the tweets are on the neutral side, and on the positive side, there are less number of tweets that we have on negative side. And this is basically the comparison of prices and the sentiment score with the variation of the sentiment score and prices along the time for various cryptocurrencies. And we did see a general trend for one particular cryptocurrency, that is Dogecoin, where we can see that whenever the sentiment score tends to rise, the price of the cryptocurrency also tends to rise, which indicates a correlation between these two. Thank you.
Thank you, Jain. Do we have any questions?
Yes, okay. I have to come up here because he can hear the voice. So thank you for the talk. The question is, have you tried to use gradient boosting regression? Because I've seen mention of linear regression, two types of linear regression and random forest. What about gradient boosting?
Hello?
You can hear, right? Hello? Can you hear? Hi. Can you hear me? Let me ask. Let me think. I don't know what to do. Give me a moment. Okay, we'll give you a moment.
Hey.
Can you hear us?
Yeah, sure. Can you please repeat the question? Sorry for the inconvenience.
Yeah, I'll repeat it. So you, from what I've seen, you've tried two types of linear regression and random forest. What about gradient boosting regressor? Have you tried it or not?
Yeah. So we actually tried a particular tree-based model, that is the random forest models, and that tends to beat the linear models. We did not try explicitly any gradient boosting based models. We went for the new use of LSTM based models, which we found to be more appropriate for this context, because we did want to incorporate some sort of historical inference into our prediction methodology, because the domain of this cryptocurrency price prediction and everything, right, this is hugely dependent on the context of time. So the prices in the future for a particular cryptocurrency do generally tend to differ based on the previous prices, and like the sort of previous I'm talking about is, it can be in terms of hours, it can be in terms of even minutes. So we went for a time context-based model, which is LSTM. We did not try the gradient boosting models. However, I do think that that sort of analysis does tend to provide some sort of insights into what the future work in this direction could be.
Okay, thank you.
Yeah, thanks a lot.
Anyone else?
Hello. Actually, you mentioned an example that some influential user like Elon Musk can heavily influence this cryptocurrency rate. Could you please,
Yes.
maybe, is it possible to return to your slides, and could you please point out the attributes of metadata that correlate to the influence of a user?
Sure, sure. Give me a moment. I'll just share my screen again. Yeah. So the sort of influence that we are talking about, right? Generally, what happens is tweets by these popular users, such as Elon Musk or some other influencer, for example, does tend to get a lot of traction from various other Twitter users, and that traction sort of can be measured in the form of the number of times that the tweet has been liked and the number of times the tweet has been retweeted. So these are two particular, and another thing could be if the user is verified. Sometimes what happens is there are a lot of bot accounts or spam accounts that tend to tweet something that receives a lot of traction from various other spam or bots. But generally what happens is Twitter does not verify such users. So we do take into account the verification status and the favorite counts, that is the number of times the tweet has been liked, and also the number of times the tweet has been retweeted, to get a sort of insight into how influential the person who has tweeted that particular text could be. So these are three particular metadata fields that I can point out that sort of captures the influence of the person that is behind the keyboard typing that tweet.
Yeah, this is particularly the reason why we have also incorporated this particular slide. It shows that how a verified user has been attracting more reaction from the users, and a person and celebrity like Elon Musk, who has a high impact on the economy, can make such a massive difference.
Maybe. Okay.
I hope that answers your question.
Yeah, probably.
Thank you.
Hello. How many data points do you need to perform this principal component decomposition reliably? Hello?
Oh, I got muted again.
I mean, in your time series, you have a certain frequency of sampling. How many data points do you need to sample to perform your principal component decomposition reliably?
So we took 1,000 points randomly from each sentiment class, and this for each particular cryptocurrencies, we have three particular classes in total for our sentiment analysis: the positive, neutral, and the negative classes. So we went for this number of 1,000 points to get a total of 3,000 points for each particular cryptocurrencies, and we plotted this PC. We did this PCA for all these 3,000 representations of 3,000 different tweets for each cryptocurrencies, and saw that the tweets with the same sentiment were being clustered together in their representation. So we took 1,000 points from each class for each particular cryptocurrency.
What's your feeling about the minimum number of data points for this analysis?
I mean, I cannot comment on a direct number. I do see the meaning behind your question, but this particular experiment was basically to see if the sentiment analysis part in our particular whole methodology is working correctly or not. That is the tweets that have same sort of contextual representation that is generated by these BERT-based models. Are they similar or not for the tweets that have same sentiment class? So this was more sort of an analytical and a verification sort of thing to see that particular sentiment analysis block is working fine or not.
Yeah, we just wanted a source of truth in a way, because we just wanted to see that, for analysis, that the corresponding sentiments have been actually trained well, and that's why PCA with 1,000 points seemed to be appropriate with the data set that we were using for each cryptocurrency as well, and they gave us pretty good results.
Okay, thank you.
Thank you.
Oh,
Okay, but maybe do you hear me right now?
I'm sorry, can you please repeat?
Yeah. Do you hear me from this side?
Yes, we can.
Yeah. Okay. Maybe this is the micro, so it's okay. Okay. Maybe the question is whether your approach as a whole is reliable, because the rate of this cryptocurrency rate actually is produced by I think a very large variety of reasons, economical reasons, and so on. And these reasons taken from social networks is only a part of factors that influenced this cryptocurrency rate. And could you characterize this approach in general? How useful it is? Actually, I do believe that cryptocurrency rate is correlated with the behavior of people in social networks. But again, it's only a part of reasons that produced this cryptocurrency rate.
Yes, you're absolutely right. It is one of the major factors. And of course, I'll stress on the fact that it is one of the major factors. There can be many. However, we just wanted to see how like social media sites, especially Twitter, how they alone can make such a heavy impact. Like, yes, there are many factors, but just a tweet from one celebrity is causing fear amongst the people that they might lose their investments, they might lose their money, and how social media alone is impacting the world in such a strong way. And which is why that was our motivation, because right now the world is moving onto the digital space, and now everyone is on social media. That is the one link that is connecting all of us, no matter where we are in the globe. Which is why it was very important to see how particularly like our social media activities is being responsible on our day-to-day decision making.
And also we can see that like the general equity markets and traditional sort of traditional assets like gold and silver, generally what we do is we do conduct market analysis that is based on the prices, almost that is based on the prices, the past prices and the economic factors alone. So what we observed was there were some recent studies that were emerging to conduct the price analysis for these assets like gold and the traditional assets like gold and silver based on the social media dynamics and the user mood. So that is what stemmed our motivation for this particular research, that we will focus on the one thing that is accessible to everyone, that everyone generally uses. Because at that time around when we started work on this particular project, there was such a hype about Dogecoin and how a particular user, which we mention again and again as our example, Elon Musk, is influencing the prices of this particular cryptocurrency. So we wanted to study this particular factor, and I do agree with you that this is not the only factor that affects the price of a cryptocurrency. There are multiple other factors like the previous prices, how the world is moving around, all the various political situations and everything. So yeah, this does conduct analysis of one particular aspect of this problem.
Yeah. Okay. Thank you.
Thanks a lot.
Thank you. We should move to the next talk. The next three talks are short, so we have to be careful with time.
Thank you, everyone.
Thank you so much.
We'll
for your
need to
time.
drop off now.
Thank you again.
Thank you.